Okay, so for this one, my preferred method would be just to sketch a graph, but you could also use test points. But I will do this as a graphing problem. So our zeros are going to be at x equals negative 12, and that's going to, so I'm going to graph it. So remember, when they're squared, they bounce, and when they're to the first or odd powers, they cross. So this zero will be at 3, and that's going to cross, multiplicity 1. This is going to be at 6, and it's also going to cross. And then if I count up my x's, I have 1, 2, 3, 4, so that's squared. So it'd be x to the fourth, and there's a negative in front. So in terms of my my leading coefficient and degree, this would be, oops, what I was writing there, negative x to the fourth. So for end behavior, we're going to expect this thing to look kind of like that, based on what that leading term is doing. So now we'll take the end behavior and the zeros and the behavior at those and put that all together in a really bad looking graph. So we've got 12, 3, and 6, or negative 12. So we call that negative 12, and we call that 3, and we call that 6. And we're supposed to start at the bottom because that's what it's going to act like, a negative x squared. We're going to come in to that negative 12. We're going to bounce off of that. And then we're going to come back and we're going to cross on the 3. And we're going to cross on the 6. So it has to have a turning point there and come back down. And now if you look, my kind of crappy looking graph does look like an upside down parabola. And we want the regions that are less than but not equal to 0. So let me change colors here. That means I don't want any of these endpoints. There's no equals on there, so I don't want to include any of those zeros. So I'm just going to go ahead and put those as open dots right now to remind myself. So all of the points that would be less than 0 then are over here up to negative 12, but you can't include it. Everything in between there works. Not there because that's positive, and then out here works. So the interval notation on this is a little tricky because you're missing that spot there, but it would be negative infinity up to negative 12. That's a parenthesis, union, and you have to pick back up at negative 12 because you're just excluding that one point. I think we want this interval notation. Negative 12 up to 3, and then union that with 6 to infinity. And then that would be the interval notation for that.